Okay. Okay. Thanks for coming. Today, so for the first part of the discussion, I'm gonna review our last homework, and then today we will have a short discussion. So after the first part, I will answer to any questions you might have. So let me begin. Okay. So assume that the sellers. Okay. So starting from question 1. We assume that seller only sells if your bid is strictly higher than the firm's value. So we denote my bid as B and value as V. So only if my bid is strictly higher than only if my B, the bid, is higher than firm's value V, I can acquire the firm. And then in this question, V is uniformly distributed in the interval 0 to 20. And then if you acquire the firm, then the value will go up by 30%. So in this case, what is your expected value from bidding B? And what is your optimal bid? Okay, so let's begin. Okay, so for each realization of V, let us think about what my return is. So for each point of V, if I acquire the firm, then what I can earn is 1.3 V minus B. So if I acquire the firm, this is what I pay. This is the value times 1.3, because we have 30% increase in the value. So this is something like point-wise revenue of my investment. And then the firm is sold only if V is greater than B. So this is saying that if I draw the realizations of V, the value, then I'm sorry, this is 20 in this question. Suppose that I bid B, then this is the range of V's that firm is sold. So if we express this as an expected value, then we can express in this way. The value pi is, I need to integrate from 0 up to B. Okay, so it's not 20. And this B is coming from the B at the left-hand side of this diagram. And each of these realizations can happen by probability 1/20. Okay, so this is coming from our assumption, uniform distribution from 0 to 20. And then what I can earn is 1.3 times V minus B. Okay, so this is coming from step 1 here. And then this is not the end of the story. We need to integrate out the unknowns of this function. V is unknown, so the value is unknown. B is known. B is what B is my bid, so I definitely know what my bid is. The only thing that is unclear for me is this V. So if I think about all the possible realizations of V, then I will know my expected value. Any questions so far? Then the final thing left to do is just integrating this. We have 1/20 here. And then if I integrate with V, I have 1.3 V squared over 2 minus PV. And then the range of this integration is from 0 to 20. Now we can forget about v equals to 0 part, because if you put 0 in this function, then everything is 0, so everything gets cancelled out. So you can just think about what happens if I substitute 20 here. Then we have 1 over 20, 1.3 times 20 squared divided by 2 minus b 20. Then this is 1 over 20. Oh, I'm sorry. I made a mistake here. It's not integrating to up to 20. Integrating up to b is correct. Oh, I'm sorry. I was out of my mind. Sorry for this one. It should be b squared b times b. Okay. Oh, sorry for this mistake. Then continued, we have 1.3b squared divided by 2 minus 2b squared over 20. This is minus 0.7b squared over 2, which is less than 0. So the term inside here is a negative thing. This is positive. So combined should be a negative term. So I will only have loss if I invest B. So for any bit B, I will have a loss. So it is optimal to bid nothing with B equals to 0. Okay. So this is negative if B was strictly positive. So yeah, so if I want to maximize the expected value, my optimal bid is 0. Any questions? Okay, good. Thank you. Then second question. Now we want to rationalize choices where people bid be greater than 0. So one of possible explanations for that is using the cursed equilibrium model, which is not correct, but we want to understand why people bid be greater than 0. So here goes the first explanation. So people think that if I bid B, then they think that so they know that they can acquire the firm so they can acquire the firm in this range, and then but they think that this probability is fixed. So think probability of acquiring firm is B over 20. Okay, but this is fixed number. So this is the main difference between what we did above and below. So they are trying to, so they think that their expected revenue goes from 0 to 20. So it's not going from 0 to B. They think that I can acquire the firm in any cases, or this probability is fixed to B over 20. So let me highlight here. It's a fixed number. And then if you saw the old answer key, this was the end. But in the new answer key, you will see 1 over 20 here. So this part was a mistake when I made the last answer key. We need to multiply 1 over 20 here, and then so this stands for the probability density function. This stands for what people think about the probability of acquiring the firm when they bid B. So this part has changed. So there will be an announcement soon from the professor. So, and then we have 1.3 B V minus B. So this is the return of the investment. And then we integrate using V. Okay, so the main difference is that we have this B hanging around at the front. So this is wrong. We should be putting 1 here and then put B in here. But people in this model are doing the wrong integration. So if I do this, then let me just put, so these parts are unaffected by the integration. So I can just focus on the first part. Sorry. I can focus on this latter part of the integration, which is 1.3 V squared divided by 2 minus BV. And then people integrate from 0 to 20. Okay. Any questions so far?
Well, actually, can you explain why we need to add a 1/20 again? Because I know when we do it correctly, we gonna use 1/20 is actually the probability density function, right? Like the
yes,
in
right.
the B/20 is technically the cumulative distribution function. So I'm just wondering, like, if we already add the cumulative distribution function, why do we need to add another probability density function when you already have a cumulative distribution function? This is my question.
So this first part is something like, probability. Yeah, so you are correct. This is like probability of acquiring the firm at each realization of V. Realization of V. And then I think we also need to think about the probability of realization of V. So this is something like, so I think there are like two layers of a probability. So the first one is thinking about what is the probability that we have one realization of V, and then for each realization of V, the guy is incorrectly thinking that I'm gonna acquire the firm by a probability B/20. So I think this is the rationale standing behind this equation. So the difference is that in here, the probability of acquiring firm is 1 or 0. So 1 if the V is greater than B, and 0 if the realization of V was less than B. So this is what is standing behind the correct equation. In the first equilibrium case, we are fixing the probability to B/20, and then multiply with and then multiplying with PDF again. Does that make sense?
Yeah, that makes sense. Thank you.
Okay, thank you. Yeah, it's difficult to explain what is wrong, and then it's difficult to explain why something wrong is correct, and why something wrong is kind of makes sense. But anyway, let me move on. Yeah, but we all know that this is a wrong model. Yeah, but the answer does not change. So the answer is the same. It's just multiplying 1/20 at the front. So in this step, now we put 20 to here. 20, right again, 20B. So if I do this, let me keep 1/20 here. For the first one, we have B times 1.3 times 20 divided by 2. Yeah, so this 20 was canceled out. And then for the latter part, we have b squared here, okay? Because in here, 20 and 20 gets canceled out, so only b squared is alive. In the front, for the front one, I just canceled out this 2 here. With these, algebra is not that important, as long as you understand what is going on. And then we have 1/20. Let me write again. 1/20. Here we have 13 times b minus b squared is the end. So this is my expected value. This is the expected value that the question was asking. And then my optimal bid. So this part is for my optimal bid. So I need to maximize my expected profit. So I differentiate with respect to b, which gives 1/20, 13 minus 2b equals to 0. And then the optimal b will satisfy 13 divided by 2, which is 6.5. So the answer does not change. Any questions for this part? Okay, thank you. Suppose the value of a firm. So why we are solving question 3? In question 1, it was a bit complicated. It was complicated because there are infinite cases of V's and B's. Okay, so in question 3, we are trying to make the question simpler. Simpler by allowing only 2 choices, 0 or 20. Then let's see what the optimal bid is in this case. So everything else is the same. If you acquire the firm, then the value will go up by 30%. And then in this question, we are trying to approach case by case. So case 1, what happens if you bid a number higher than 20? And then in this case, the expected, we can think about expected revenue and expected cost. Oh, I'm sorry. Or if this is obvious, you can do everything in one step. That's fine. I'm just trying to go step by step. So expected revenue is that something, whatever the realization is, the value of the firm will be boosted by 30%. So I multiply 1.3. It can be either 0 or 20. And then each of the realization of V has the probability 1/2. So I divide by 2. In any cases, I acquire the firm. So I subtract B. Okay, so in any cases, the firm is acquired. I was doing 2 things at once. So in here, expected cost goes here. So in any cases, the firm is acquired, and this is the expected revenue from this investment. Okay, so putting together, pi equals to 1.30 plus 20 divided by 2 minus b. This is 13 minus b and less than 0. Because this b, this guy is greater than 20. Obviously, it's greater than 13. So the whole value will be less than 0. Case 2, I made a mistake in the answer key. And then our kind professor corrected the answer key and uploaded it again. So in this case, let us think about b greater than 0 and less than 20. Then expected revenue. Now in this case, firm is only sold is sold only when the value is 0. Because if I bid something less than 20, so suppose that 20 is here, and suppose my bid is here, then the seller will only sell the farm if the true value is greater than B. But we only have two realizations, 0 or 20. So the farm will be never sold if the value was 20. So we only think about the case when the value is 0. So expected revenue is 0. It should be 1.3 times 0, okay, divided by 2. This is 0. And then the expected cost is B divided by 2. So this was my mistake. In the previous answer key, it was just B, which was wrong. The correct answer is B over 2, because by 50% of chance, the farm is sold. So combining all the result, the answer is 0 minus B over 2, which is still less than 0. So in all cases where B is strictly greater than 0, the expected value of this investment is negative. So the optimal bid is B equals to 0. Yeah, so this is the answer for this question. Any questions about this one? Okay, then let me stop the recording. And then if you have any questions, let me know.